Okay, hello everyone in a new video. So we have reached part 6 of chapter 3, which is the chapter of DC voltage and the second unit of electricity. So in this one we are going to solve some exercises related to this chapter. Now exercise number 1, they are telling me document 1 shows an electric circuit consisting of a DC voltage source such that UPN is equal to 12 volts. So the trick in solving such type of exercises is to write the voltage on the electric circuit itself. So the voltage of the battery is given by 12 volts. Connected to this source we have 3 lamps given by lamp L1, L2 and L3. So these are the lamps L1, L2 and L3. The lamp L1 comes with the following indication, which is given by 4 volts, and K is a switch, and the given ammeter is of negligible resistance. So notice that I didn't write this indication on the electric circuit because yet we don't know if the lamp L1 is functioning normally. So part 1, they are telling me that initially the switch K is opened. So 1.1. What is the voltage UEN across the open switch? We know that an open switch in series with the battery have the same voltage of the battery. Therefore, let's write an open switch in series with the battery has the same voltage of the battery. Therefore, the voltage UEN is equal to 12 volts. Now in 1.2 they are telling me, is there any current traversing the circuit? Justify. Because the switch K is an open switch, and we know that an open switch doesn't allow electric current to pass through. Therefore the value of the electric current is 0, which means there is no electric current traversing the circuit. Then let's write an open switch doesn't allow electric current to pass it through. Then in this case the value of the main current is equal to 0. Now in number 2 they are telling me now the switch K is closed and the lamp bulb is functioning normally, and we have that UDE is equal to 5 volts. So the voltage across the lamp L3 is given by 5 volts, and moreover they are telling me that the lamp L1 is functioning normally. So because the lamp L1 is functioning normally, then the applied voltage which is given by UVC will be equal to the rated voltage, or the indication, which is given by 4 volts. Now in 2.1 they are telling me, what does the indication 4 volts mean? So 4 volts, it is the rated voltage. Why the rated voltage? Because it has the unit of volts, a voltage which is given by volts. Of which lamp? Of the lamp L1, under which it functions normally. Now in 2.2 they are telling me, justify that UBC is equal to 4 volts. Now the voltage UBC is the voltage across the lamp L1, and we already know that the lamp L1 is functioning normally. Therefore the applied voltage which is given by UBC will be equal to the rated voltage, which is given by 4 volts. Then let's say, since the lamp L1 is functioning normally, then the applied voltage, is equal to the rated voltage. So in this case we have that UVC is equal to 4 volts. Now in 2.3 they are telling me UAN is equal to 0. So here let me close the switch, because in number 2 they are telling me now the switch is closed. Now let's continue. In 2.3 they are telling me UAN is equal to 0, justify. So UAN represents the voltage across the closed switch, and we know it's equal to 0 because it acts as a connecting wire. So UAN now in 2.4 they are telling me UAB is equal to 0, justify. So UAB is the voltage across the ammeter, and the voltage across the ammeter is 0 because the ammeter is of negligible resistance. Then 2.4, the voltage negligible resistance. Now in 2.5 they are telling me deduce that UCD is equal to 3 volts, and the word deduce means that we need to use the part just previously before. In parts 2.2, 2.3 and 2.4 we have talked the voltage across certain branch, so maybe we'll use these values later in order to calculate the voltage across another branch using the law of addition of voltages. And indeed, because they are telling me UCD is equal to deduce that UCD is equal to 3 volts, so the only unknown voltage in this electric circuit is across the lamp L2, which is given by UCD. Therefore we can apply the law of addition of voltages to calculate the voltage UCD across the lamp L2. Then let's say apply law of addition of voltages. So how do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN, and on the right we write the voltage across different electric components starting from P and ending with N. And recall that always in physics we need to mention the law that we are using. So we will go from P to A across the connecting wire, from A to B across the ammeter, from B to C across the lamp L1, from C to D across the lamp L2, from D to E across the lamp L3, and from E back to N. Now the voltage of the battery is given by 12. Now UPA is equal to 0. Notice that we didn't justify previously why UPA is equal to 0. So here between the brackets, UPA is equal to 0, and the reason is given by connecting wire. Here the unknown that we need to calculate is given by UCD, so we keep it as a variable. Moreover, UAB is equal to 0 because the voltage across the ammeter is 0 from part 2.4. Now UBC is given by 4 because the lamp is functioning normally. The voltage UCD that we want to calculate. Now the voltage UD is given by 5 volts given in part 2. And UDE, okay, this is UDE, and UEN is equal to 0. Close the switch, is justified in part 2.3. Therefore 12 is equal to 9 plus UCD. So UCD is equal to, this is a linear equation and one unknown. The unknown is given by UCD. Since 12 is in volt and 9 is in volt, then the voltage UCD will be in volts, which is 3 volts. So UCD is equal to 3 volts. Now in exercise number 2, they are telling me document 2 shows an electric circuit consisting of a DC voltage source such that UPN is equal to 24 volts. And 3 lamps given by L1, L2 and L3. An oscilloscope is connected across the lamp L3 and K is a switch. Before I solve this exercise, let me correct something. Here in part 2, it should be closed. Let me do it this way. Now number 1, they are telling me initially the switch K is opened. Now in 1.1, they are telling me what's the voltage UDE across the switch. So notice that K is an open switch that is in series with the battery, and we know that always an open switch in series with the battery has the same voltage of the battery. Then let's say an open switch in series with the battery has the same voltage of the battery. Therefore, in this case, UDE is equal to 24 volts, which is the voltage of the battery. Now in 1.2, they are telling me, is there any electric current traversing the circuit? Justify. We know that an open switch doesn't allow electric current to pass through. Therefore, the value of the electric current is 0. So an open switch doesn't allow therefore the value of the main current traversing the circuit is 0. Now in part 2, they are telling me the switch K is closed and we have that UAB is equal to 5 volts. So the voltage of the lamp L1 is given by 5 volts. Moreover, on the screen of the oscilloscope, we observe a luminous line displaced upward. So the luminous line is displaced upward. Let me close the switch. So displaced upward means that the value of y is positive. So what does y represent? The number of divisions displaced by the luminous line on the screen of the oscilloscope. And they are telling me displaced upward by 3 divisions. So the value of y is given by 3 plus 3 divisions. When its vertical sensitivity is adjusted to SV is equal to 1.5 volts per division. Then in 2.1, they are telling me, does the oscilloscope measures UCD or UDC? And this is can be known by referring to the electric circuit. Notice that the phase terminal is connected to the point C and the mass terminal is connected to the point D, and always the oscilloscope measures from the phase terminal to the mass terminal. Therefore, the oscilloscope measures UCD. Now, since the phase terminal is connected to C and the mass terminal is connected to D, then the oscilloscope measures UCD. Now in 2.2 they are telling me calculate the voltage measured by the oscilloscope, and this is done using the formula U is equal to the vertical sensitivity multiplied by the number of divisions Y. Notice that in part 2.1 we have justified that the oscilloscope is measuring the voltage UCD. Then instead of writing U, we write UCD. Now the vertical sensitivity is given by 1.5 and the value of Y is given by +3. This will give us let me say 4.5. Since Y is in volts and SV is in volts, then the value of the voltage U will be in the SI. Sorry, because Y is in the SI and SV is in the SI, so the value of U will be in the SI, which is given by volts. Therefore, UCD is equal to 4.5 volts. So I repeat always the trick in such type of exercises to write the voltage on the electric circuit itself. So the voltage UCD is given by 4.5 volts. Now in 2.3 deduce the voltage UVC across the lamp L2, and deduce means that we need to use the part just previously before. Previously we have talked about the voltages across certain branches. So probably we might use these voltages to calculate the voltage across another branch using law of addition of voltages. And indeed, if we refer to the electric circuit, we know the voltage of the battery, voltage of the lamp L1, and the voltage of the lamp L3. The only unknown voltage is across the lamp L2, which is given by UVC, and this can be calculated using the law of addition of voltages. And how do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN, and on the right on the other side we will write the voltages across different electric components starting from P and ending with the point N. So from P to A across the connecting wire, from A to B, from B to C, from C to D, from D to E, and E back to N. Now voltage UPN is equal to 24, voltage of the battery. UPA is 0, and the reason is given by connecting wire. So we didn't justify this previously, so here between brackets UPA is equal to 0, and the reason connecting wire. And the voltage here that we want to calculate is UBC, so we keep it as a variable. Now UAB is equal to 5 given, plus UBC. Now the voltage UCD is equal to 4.5 from part 2.2. Now UDE is equal to 0, and the reason, so across D and E we have a closed switch, so UDE is equal to 0, closed switch. And UEN is equal to 0, and the reason is given by connecting wire. Then 24 is equal to UBC plus 9.5. So UBC is equal to 24 minus 9.5. So this will give us 14.5. Since 9.5 is in volts and 24 is in volts, then the voltage UBC will be in volts. Then UBC is equal to 14.5 volts. Now in exercise number 3 they are telling me document 3 shows an electric circuit consisting of a dry cell delivering a DC voltage given by UPN is equal to 12 volts. The two lamps L1 and L2 are identical, this is important, and carrying the following indication 6 volt. So this indication, we don't write it on the electric circuit because we don't know yet if the lamps L1 or L2 are functioning normally. Now in number 1.1, they are telling me what is the voltage across the switch K. Notice that here K is an open switch because they told me that initially the switch K is open, and we know that an open switch in series with the battery have the same voltage of the battery, which is given by 12 volts. So an open switch in series with a battery has the same voltage of the battery. So in this case, UAB is equal to 12 volts. Now in 1.2, they are telling me, is there any electric current traversing the circuit? We know that an open switch doesn't allow electric current to pass through, therefore the value of the electric current is equal to 0. An open switch doesn't allow Now in number 2, they are telling me the switch K is closed. Let's close the switch. In 2.1, show that UBD is equal to 12 volts. So what does UBD represent? UBD represents the voltage across the lamps L1 and L2, and this can be done using law of addition of voltages, because we know that UAB is equal to 0 volt and UDE is equal to 0 volt because the ammeter is of negligible resistance, and we have that the voltage of the battery is given by 12 volts. Then apply law of addition of voltages. How do we apply this law? Always on the left we write the voltage of the battery, which is given by UPN, and on the other side we write the voltages across different electric components starting from P point and ending with N. So from P to A, notice that here they are telling me show that UBD is equal to 12 volts. So we require that UBD must appear in the equation. Therefore, okay, from A to B, because we want UBD to appear in the equation, we will go from B to D directly without going across the point C. Therefore, UBD plus UDE plus UEN. So UPN, this is the voltage that we want to calculate, is UBD. The value of UPN is given by 12. UPA is equal to 0, and the reason is given by connecting wire. We didn't justify this previously. And the value of UAB is equal to 0 because across A and B we have a closed switch. Therefore UAB is equal to 0, close the switch. And we keep UBD as an unknown because we want to calculate it. Now UDE is equal to 0 because across D and E we have an ammeter of negligible resistance. So UDE is equal to 0, negligible resistance. And UEN is equal to 0, and the reason is given by connecting. Wire. And this gives us that UBD is equal to 12 volts. So the voltage UBD across the lamps L1 and L2 is given by 12 volts. Now in 2.2 they are telling me deduce the voltage UVC and UCD across the lamps L1 and L2. The word deduce means that we need to use the part just previously before. So knowing that the lamps L1 and L2 are identical, so both of them will have the same voltage, and we already proved in part 2.1 that the voltage across each of the voltage across both of them is given by 12 volts, and because they are identical, then each one will have an applied voltage given by 6 volt. Then in part 2.2, let's say since the lamps L1 and L2 are identical, then they have the same voltage. So what's the voltage across the lamp L1 is given by UVC, and what's the voltage across the lamp L2 is given by UCD, and this is equal the voltage across both lamps, which is given by UBD, divided by the number of lamps, which is equal to 2. So 12 divided by 2, this will give us 6. Since UBD is in volts, so the value of UBC and UCD will be in volts. So UBC is equal to 6 volts and UCD is equal to 6 volt. Now in 2.3 they are telling me what does the indication 6 volt mean. So the indication 6 volt is for the lamps L1 and L2. So 6 volt is the rated voltage because it has the unit of volts of the lamps L1 and L2 under which they function normally. Now in 2.4 they are telling me deduce that the lamps L1 and L2 are functioning normally. In part 2.2 we have deduced that the voltage UBC across the lamp L1 is 6 volt and the voltage across the lamp L2, which is given by UCD, is equal to 6 volt, and this is equal to the rated voltage. Therefore the lamps L1 and L2 will function normally because the applied voltage is equal to the rated voltage. Now since the applied voltage is equal to the rated voltage, then the lamps, so what does this mean? 6 volt is equal to 6 volt. Then the lamps L1 and L2 will function normally. Now in exercise number 4 they are telling me document 1 shows an electric circuit consisting of a DC voltage source such that UPN is equal to 24 volts, 3 lamps given by L1, L2 and L3. The lamp L3 comes with the following indication 12 volt. So L3 comes with the following indication, which is 12 volt. An ammeter A of negligible resistance, an oscilloscope connected across the lamp L2, a switch key. Now in number 1 they are telling me initially the switch key is opened, so 1.1. What is the voltage UDE across the open switch? We know that always an open switch in series with the battery have the same voltage of the battery, which is given by, in this case, 24 volts. So an open switch in series with the battery. Has the same voltage. So in this case, UDE is equal to 24 volts. Now in 1.2 they are telling me, is there an electric current traversing the circuit? Justify. We know that an open switch doesn't allow electric current to pass through. So the value of the electric current I is equal to 0, which is the main current traversing the circuit. Now in 1.3 they are telling me, what does the indication 12 volt of the lamp L3 means? So 12 volt is the rated voltage because it has the unit of volts. Now this indication is for the lamp L3 of the lamp L3. Under which it functions normally. Now in number 2 they are telling me, now the switch key is closed. Let's close the switch. Hence, a luminous line is displayed on the screen as shown in document 2. So they mentioned document 2, and now I can use it. So in document 2 we have the screen of the oscilloscope. This is the luminous line that is displaced upward the moment we close the switch key. So in 2.1 they are telling me, does the oscilloscope measures UBC or UCB? And this can be known by referring to document 1. So notice that the phase terminal of the oscilloscope is connected to the point B and the mesh terminal is connected to the point C, and we know that the oscilloscope always measures from the phase terminal to the mesh terminal. Then the oscilloscope in this case measures UBC. Since the phase terminal is connected to B, and the mesh terminal is connected to C, then the oscilloscope measures, in this case, UBC. Now in 2.2 they are telling me, calculate the voltage measured by the oscilloscope, and this can be done by referring to document 2, given by the formula U is equal to SV multiplied by Y, where SV is the vertical sensitivity and Y is the number of divisions displaced by the luminous line on the screen of the oscilloscope. Now in 2.1 they told me, because or we have justified that the oscilloscope measures UBC, so here it's better to write UBC. Now the vertical sensitivity is given here on the screen of the oscilloscope, so 3. And because the luminous line is displaced upward, so the value of Y is positive, and the number of divisions displaced by the luminous line is given by 1, 2. This will give us 6. Since Y is in the SI and SV is in the SI, so U is in the SI is given by volts. So UBC is equal to 6 volts. Now in part 3 they are telling me the lamp L3 is functioning normally. So what does this mean? We know that the lamp L3 comes with the following indication, 12 volt, and since it's functioning normally, then the applied voltage which is given by UCD will be equal to the rated voltage which is given by 12 volts. Now in 3.1 they are telling me what's the value of the voltage UCD across the lamp L3. It is 12 volt because the lamp L3 is functioning normally and it comes with the following indication, 12 volt. So the applied voltage is equal to the rated voltage. Since the lamp L3 is functioning normally, then the applied voltage is equal to the rated voltage. So UCD is equal to 12 volts. Now in 3.2 they are telling me UPA is equal to 0, justify. Across P and A we have an ammeter, and we know that UPA is equal to 0 because the ammeter is of negligible resistance. Now in 3.3 they are telling me UD is equal to 0, justify. Across the ND we have a closed switch, and we know that the voltage across a closed switch is 0 because it acts as a connecting wire. Now in 3.3 they are telling me UEN is equal to 0, justify, and this is because across E and N we have a connecting wire. So the voltage Now in 3.4 they are telling me calculate the voltage UAB across the lamp L1. So here in the electric circuit the voltage of the battery is known, as well as the voltage of the lamp L2 and L3. UPA is 0 and UDE is 0 as well as UEN. Therefore the only unknown voltage is given by the voltage across the lamp L1, and this can be calculated using the law of addition of voltages. So apply law of addition of voltages So how do I apply this law? Always on the left we write the voltage of the battery which is given by UPN, and on the right we write the voltages across different electric components starting from P and ending with N, then from P to A to B, B to C, C to D, D to E, and back to N. Now the voltage that we want to determine is UAB. UPN is equal to 24 given, UPA is equal to 0 justified, UBC is equal to 6 calculated, UCD is equal to 12 justified, UD is equal to 0, and UAN is equal to 0 justified. Then 24 is equal to UAB plus 18. Then this is a linear equation and one unknown, which is given by UAB. UAB is equal to 24 minus 18. This will give us 6. Since 24 is in SI, which is volts, and 18 is in volts, then the value of UAB will be in volts, which is given by 6 volts. So UAB is equal to 6 volts. So that's it for me in this video, guys. Hope it was beneficial for you guys out there watching it, and see you soon in another one.